In section 8.5, we're going to talk more about different parts of a circle and finding more perimeters or areas of parts of a circle, basically a segment and a sector. And then also we'll talk about inscribed circles or inscribed triangles in a circle. All right, so we have a new word here, sector. The sector of a circle, think of it as a piece of pizza. The sector of a circle will always have its vertex as a central angle, and we're talking about this entire piece of the circle. It has an intercepted arc, it has a central angle, and if we want to find the area, we're finding the area of the shaded part of the circle. So that's what a sector looks like. And we're going to use the fact that the relationship, the proportions hold. The sector information will be in the numerator, and the whole circle information will be in the denominator. So it could be the central angle of the sector over 360, because that's how many degrees are in the a central angle of a whole circle. It could be the arc length of the sector over the circumference, which is the distance around the entire circle, which we've seen before. Or it could be the area of a sector as it relates to the area of the whole circle. So as we look at these two examples, here I have a sector whose central angle is 90 degrees. The central angle of the sector is 90 degrees. All the angles of a circle are 360. That reduces to 1/4, and this is actually 1/4 of the entire circle. If you cut the circle into 4 equal parts, that sector is 1/4 of the whole circle. Here we have a central angle of 120 degrees. Well, the sector has a central angle of 120, and the circle has included angles of 360 degrees in a full circle. Well, that would reduce to 1/3. So this arc length is 1/3 of the entire circumference, but this sector takes up 1/3 of the whole circle. So its area is going to be 1/3 of the whole circle. So here's our equation down here. We're going to rely on the proportion that the area of the sector is to the area of the whole circle has the same relationship to the central angle of the sector to 360. So area of a sector is going to be whatever the central angle is over 360 times pi times the radius squared. Pi times the radius squared is the area of the whole circle. We're going to multiply that by 1/4 if we were talking about our 90-degree angle. We're going to multiply that by 1/3 if we're talking about our 120-degree angle. All right, so let's go on with an example here. All right, so in this example, our central angle is 100 degrees. And they want us to find the area of the 100-degree sector. And they say use your calculator. So we're just going to hit the pi key on our calculator, and then at the end round your answer to the nearest hundredth. So that's to 2 decimal places at the end. So the area of the sector is, we have 100 of the 360 degrees of a whole circle. Pi times the radius squared. Our area is going to be 100 over 360 pi, and we're told, where's our radius? Oh, we're told that our radius is 10 inches. So this is 100 over 360 times pi times 100. And when you put this in your calculator using the pi key for the value of pi, the estimate of the value of pi, we're going to get that our area is approximately 87.27 to 2 decimal places square inches. So up until now, the examples have said use 22 over 7, or they've said use 3.14, or they've said use the pi key in your calculator to estimate pi. But if they ask for exact answers, you're going to leave pi in your answer. All right, so if I had, for instance, a circle of radius 5, what would be the circumference with a circle of radius 5? Circle is pi times the diameter. So the circumference is pi times 2r. So my circumference would be pi times 2 times 5. So my circumference would be 10 pi inches. That's exact. That's the exact circumference. We're leaving pi in the answer. What would be the area of the circle with radius 5 inches? Well, area is pi times the radius squared. So our area is going to be pi times 5 squared. So my area would be 25 pi square inches. That would be my exact answer. I would not try to put in a different value for pi. I'm just going to leave pi in the answer. So read your instructions and see if they want you to give an exact value for pi or an exact answer, or if they want you to estimate. And if they want you to estimate, they will tell you which to use.